Good morning, friends. Today we'll discuss some problems about the quantum numbers. Okay, so let's come to the question number 1. All the quantum number of rubidium in the valence cells. All the quantum number of rubidium in the valence cells. Rubidium belongs to 1a group, and what are the 1a group elements? Hydrogen, lithium, sodium, potassium, rubidium, cesium. So rubidium has the outermost electronic configuration 5s1, 5s1. Okay, because it belongs to the row 5 and 1a group. So for 5s1, what are the quantum numbers? So as it is 5, the electron resides in 5s orbitals. So n equal to 5 and l equal to 0 because it resides in the s subcell, and as it has no orientation, its m value is 0, and we are assigning spin quantum number as the plus half. We have taken the notation: if the electron revolves in the clockwise manner, the spin will be plus half, and if it revolves in the anti-clockwise manner, the spin will be minus half. The next question for copper 29, the total number of electrons having L equal to 2 and mod M equal to 1. So this is the electronic configuration of copper. It is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. So it has asked here L equal to 2 and mod M equal to 1. L equal to 2 means when L equal to 0, it is S subcell. L equal to 1 means P subcell. L equal to 2 means D subcell. So L equal to 2 means D subcell. Okay, so for L equal to D subcell. So in the D subcell, this is the 3D subcell. In this D subcell, we have to assign the total number of electrons, in particular when the mod M equal to 1. So that means we have to take the values of magnetic quantum number, both plus half and minus half. So in D subcell, how many orbitals are there? There are 5 orbitals: dxy, dyz, dxy, dyz, dzx, dx square minus y square, dz square. So these are the 5 orbitals in the D subcell. So 1, 2, 3, 4, 5. Now in these 5 orbitals, we have to accommodate 10 electrons. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now the values of magnetic quantum number varies from minus L to plus L through 0. So here L value is 2. So value will be minus 2, 2 plus 2 through 0. So minus 2, minus 1, 0, plus 1, plus 2. So but we have to take both the minus 1 and plus 1. So the number of electrons will be here 1, 2, 3, 4, because in a given orbital maximum 2 electron can be accommodated. So here 2, here 2. So total 4. The question answer will be 4. Correct set of quantum number for 3d7. So this is the 3d subcell. There are 5 orbitals: 1, 2, 3, 4, 5. So you have to assign 7 electrons here: 1, 2, 3, 4, 5, 6, 7. We have to speak about this 7th electron, all the quantum number set. So here 3, that means n equal to 3, and for d L equal to 2, and we have to assign the m value for this electron. Here m value is minus 1, so m value is minus 1, and as this electron is clockwise manner and this our constant electron is revolving in the anti-clockwise manner, so we are assigning here spin quantum number is minus half here. Now the orbital angular momentum of a p electron is given by p electron. We know when L equal to 0, it is S subcell. When L equal to 1, it is P subcell. So for P, L equal to 1. Okay, and its formula is L. Orbital angular momentum formula is L into L plus 1 root into h by 2 pi. So simply in place of L, just you have to put the value 1 and we'll get the answer h by root 2 pi. Now the next question is maximum number of electrons for n equal to 4 and m equal to 0. N equal to 4 and m equal to 0. That means we have to speak about the 4th orbit. In the 4th orbit, how many electrons are there whose values will be m equal to 0. In the fourth orbit, how many electrons are there whose value m equal to 0? So when n equal to 4, when l equal to 4, that means principal quantum number is 4. At the time, the azimuthal quantum number l is how much? So its value 0 to n minus 1. That means 0 to, here in place of n I will put 4 minus 1, so 0 to 3. So 0 1 2 3. So 0 means s, is means p, 2 means d, 3 means f. So when in fourth orbit, how many subcells are there? S subcell, p subcell, d subcell and f subcell. So these are the subcell. This is s subcell, this is p subcell, this is d subcell and f subcell. So now we know how many orbitals are there in a particular subcell, in S1, in P3, in D5, in F7. Okay, so now very carefully we have to count the number of electrons whose m value is 0. So when the electrons resides in 4s orbitals, it's obviously its m value is 0, and for p we know the values varies from minus 1 to plus 1 through 0, and here the values varies from minus 2 to plus 2 through 0. So minus 2, minus 1, 0, plus 1, plus 2. Similarly here the minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Okay, so we have to count the only electron whose m value is 0. M value is 0. So here m value is 0, and here m value is 0, and here m value is 0, and here m value is 0. So how many electrons can we accommodate here? Here 2, here 2, here 2, and here 2. That means 8. So the answer will be 8. Now the last question is, how many electrons are there in quantum? How many electrons is possible for this quantum number? If quantum number is mentioned n equal to 4, ml equal to 1, and ms equal to minus half, then how many electrons are possible? Similarly, same way, so n equal to 4 means there are 4 subcells s, p, d, f, s, p, d, f, and we know the number of orbitals here. So here we have to take ml equal to 1 and ms equal to minus half. Okay, ml 1. So that means here we have to take mod 1. That means we have to take both the value minus 1 and plus 1. So this is minus 1, this is plus 1, this is minus 1, this is plus 1, this is minus 1, and this is plus 1. Okay, now we can, this orbital can accommodate maximum 2 electrons. If it is revolving clockwise, we will give an plus half notation, and if it is revolving anti-clockwise, we will give the notation minus half. But here we are restricted only to take the electrons having anti-clockwise rotation. So here I will assign 1 electron, here assign 1 electron, 1 electron, 1 electron, here 1 electron, here 1 electron. That means 1 2 3 4 5 6. So the answer will be here 6. Okay, so okay, this way we have to approach all the problems regarding the quantum numbers. Okay, goodbye.